and I link all these points together. Don't mind my diagram, okay? It's a funny diagram. Are you there? The shape obtained is called what? A circle. For a circle, all the points from the locus, this, they are called what? The locus of a point. They are what? An equal distance from a fixed point called what? The center. This is the center point, Abi. This center point has a coordinate called what? H comma what? K. H represents what? The S what? Axis. What's your K? The Y axis. So we use H comma K to represent the center of what? Of a circle under coordinates what? Geometry. So we say that a circle is the locus of a point in equal distance, Abi, from a fixed point called what? The center. That means from this point here, down here is what? Is 4. From here is what? Is 4. Here is what? Is 4. Here is 4. Is 4. Even from here to here is also what? 4. Every point here, they are all what? They have distance what? Somebody? Distance 4. Are you following me? So this is what defines what? A circle. Then if we now have something like this, let's say we have 4, yeah? Here we have what? Let me say here we have 4. Here we have what? 4. Then we have 8. Then we have what here? 8. Can this form a circle? By the time we link all of these together, we form what? Height. We form an ellipse. In an ellipse, we have two axes. We have the major axis and the minor what? Axis. The major axis is always from here to here. It's called 2A. It's called what? 2A. From this region to this point is point A. Here it's called what? Point A. Are you there? So A plus A will give us what? 2A. The longer side in an ellipse is called what? The major axis, and it's given as what? 2A. What the shorter side is called what? The minor axis, and it's given as what? 2B. So from this point here, it's called what? 2B. Where here is B, here is what? B. Are you following me now? This graph you are seeing, all of them, they have their own formula and equation. But let's look at circle. Then when it now comes to parabola, then there's a line here. This is called what? Parabola. A parabola is just like saying when a circle is being divided into 2 and this part is being taken off, this will form what? Somebody? A parabola. Are you following me? To form what? A parabola. Then there's a point here called what? The directrix. Directrix is a line from this point here to this point, from the focus to the edge of the what? Parabola, equals from here to what? To here. So if here is 2, here is also what? 2. This line is called what? The directrix. I'm not going to parabola now, but let's start with the small one called what? Circle. Have I defined a circle to you?
Yes.
Now, put this down of you. Then when you now see something like this, having 2 different parabola, one facing here, one facing this side, it's called what? Hyperbola. Right there. In hyperbola, we have 2 foci. We have our F1 and what? And F2. Are you following me? We are coming to all of this. If you can understand this, you have covered 50% of your Math102. That's why I said I can take this course within 1 month. I'm done. You have covered 50%. This is the most complex topic in Math102, and I'm starting with this. Now that your brain is still fresh to receive. But if you enter the middle, a lot of you will start getting tired. So let's start. Sorry. Let's clear as small. Alright. So we have defined a circle as what? The locus of a point in equal distance from a fixed point called what? The center. And you say that for a circle, center is what? H comma what? K. Am I communicating? Now, given the graph below, I want to show us how to get the equation of a circle. Very important. If you have a graph or we have the circle, we have the center, right? We say what defines the circle is that all the points from the locus to the center are what? Are equal. Good. So if I have this, here we call it what? H comma what? K. Abi? The locus points, if I have a locus point situated at this point here, not this point here. If I have a point here called S comma what? Y. Locus points, we use what? S and Y to represent them. If it's there, you'll be what? S1, Y1. Yes, S1, Y1, S2, Y2. If it's there, S3, Y3. Yeah. Are you following me? Just that way and all that. So if I have a graph of this form, where the locus is what? S comma Y, which is P. What's our center? This is our center C, right? C is what? H comma what? K. Then if I have to complete this diagram by forming what? What do we call this? What do we call this diagram? Math student, what do we call this diagram? A logo. It's called what? It's called what? Right angled what? Triangle. You're looking at me as if it's new. If you don't know it, that means you go back to primary what? Primary 2. Oh yeah, watch. This is a triangle, right? Now, in this triangle, from your C to your P is called what? The radius. Abi, be aware. Like in every circle, we have what? A radius. Radius half is called what? Diameter, right? Dividing this into two, we form what? We form what? Radius, radius, radius. Abi, is it not so? And that what again? Radius. That means from this point here, radius are what? Equal. So from here, if here is 4, here also 4, 4, 4. So all the radius line are what? They are the same, they are equal in length. This is what forms what? A circle. It's also, if I now increase this by 4, this by 4, it forms what? An ellipse. Good. So for this, radius is what? Is R. So my CP is called what? The radius of what? The circle. Am I communicating? Then let's find this coordinate point. This is the S what? Axis. This is called what? The Y axis. To find this S axis, I will just subtract this H from where? From P, from X. I have my CP, Abi. To find here becomes what? H minus what? X. Here becomes what? You can tell me? K minus Y. Sorry, S minus H, sorry. S minus H. Here becomes what? Y minus what? K. The value for C, let's call it C, P. Give me something, let's represent it with something. Also 10. M, Abi. So my CM is what? S minus H. What's my PM? Y minus K. How do we get this? We subtracted what from where? This from this, Abi, to form this. Why this from this to form what? This. Now, how do we find the value of our radius? Who can tell me? I'll use your Pythagoras what? Theorem. Isn't it so? So using my very good friend from secondary school, Pythagoras what? Theorem. Yes, he died out of too much reading. So we have CP, don't mind me, I'm joking. CP squared, the rule says what? The theorem says what? The square of what? The hypotenuse equals what? Square of the adjacent plus square of what? Opposite. Is it making sense? Yes, so that means my CP what? Square equals what? CM what? Square plus what? Somebody help me. PM what? PM square. Am I communicating? Are you following? What is that CP? R. R square equals what? What is my CM? S minus H. All what? Square. Plus give me Y minus K. Y minus what? K. All what? All square. This is called the standard. The what? Standard equation of what? Of a circle. Of a what? Circle. When the circle is away, is what? Away from the what? From the origin. From what? The origin. Why is the circle away from the origin? Do you know why? Because we have a deviation. We have minus h and what? Minus k. Are you following me now? If I don't have minus h, I don't have h and k, that means the circle is where? At the origin. At the origin is when the value of our center is what? 0, 0. Abi? That means that my h is 0, my k is what? 0. Is not it? What's origin? When the circle, let's say this is our coordinate point, and the circle is lying exactly at the origin. That means the value of my h, k at this point is what? 0, 1, 0. Abi? Are you following me now? So by the time I put the value of my h at 0, here becomes what? S square. What about k at 0? Here becomes what? Y square. Is it not? So that means here becomes what? R square equals S square plus Y square. That equation form is called what? Of a circle, when the circle is where? At the origin. Put this on first, right? Right. I will repeat again, right? This for the origin, yes. Because I have minus h and what? Minus k. That means the circle deviated away from the origin. Do you get? But if the circle is at the origin, that means the value of my h and k must be what? 0. Just put it down first. Put it down. Note, when the circle is at what? At the origin. What do you say happened to the value of h? It means what? H, k equals what? 0, 0. Abi? So here becomes what? Give me the value. R square equals what? S minus 0 square plus what? 1 minus what? 0 square. So R square equals what? S square, Abi? Plus what? Y square. This is what? Standard what? Standard equation of a circle when the circle is where? At the origin. Abi? Please, second. Do what somebody? Okay. When the circle is at the origin, R square equals what? S square plus what? Y square. It's graph. Can I clear here? The graph. Are you not writing it before? Okay, yes, I've not yet done. Oh, take from others. I've only played this. Put this down. General equation of a circle. General what? We're gonna have a circle. General, we have S square plus Y square plus 2GS plus 2FY plus C equals what? 0. For this general, our center is always what? You can tell me. Is H, what? K, Abi? Which is equals to what? Minus G, what? Minus F. Then the radius of this circle for the general equals square root of G square plus F square minus C. I am done. This is all about circle. We'll start solving some problems. You will appreciate this course.